Hello and welcome to G Fun Facts Online, the show that dives deep into the science behind your everyday life. I'm your host, and today we're talking about something most of us have used, but few of us truly understand. Picture this: you're at the beach, or a park, or just stepping out for a walk on a bright day. You reach for a bottle, squeeze out a dollop of cream, and smooth it onto your skin. It's a simple ritual, but what you're actually doing is deploying a highly sophisticated microscopic defense system. You're putting on an invisible shield. Today, we're unveiling the incredible science of sun protection. We're going to demystify sunscreen, from the invisible rays it fights to the chemical magic happening on your skin. Every time you use sunscreen, you're engaging with a marvel of chemistry and physics. So let's get started. The sun, our life-giving star, is about 93 million miles away. Yet, it constantly showers our planet with a torrent of energy. This energy, in the form of electromagnetic radiation, is what makes life possible. But hidden within that sunlight is an invisible aggressor, a form of energy that can cause some serious harm. I'm talking about ultraviolet radiation, or UV for short. To really get a grip on how sunscreen works, we first need to understand the enemy it's designed to fight. Sunlight is a whole spectrum of radiation. We see the part called visible light, the reds, the blues, the greens. But there are wavelengths our eyes can't detect, like infrared, which we feel as heat, and on the other side of the spectrum, ultraviolet. UV radiation itself is split into three main categories based on its wavelength, which you can think of as the length of each individual energy wave. These are UVA, UVB, and UVC. Let's start with UVC. These rays have the shortest, most energetic, and most damaging wavelength. They are cellular destroyers. But here's the good news: you don't need to worry about them. Fortunately for all life on Earth, our planet's atmosphere, specifically the ozone layer, does a fantastic job of absorbing virtually all UVC radiation. So, unless you're an astronaut, UVC isn't a direct threat. Next up is UVB. These rays have a medium wavelength. The ozone layer filters out most of them, but a significant amount still reaches the Earth's surface. UVB is the primary reason you get a sunburn. When you feel your skin getting hot, red, and painful after a day in the sun, you can thank UVB rays. More seriously, UVB radiation directly damages the DNA within your skin cells. Your cells have repair mechanisms, but if the damage is too great or happens too often, these repairs can fail, leading to mutations that can cause skin cancer, including the most dangerous form, melanoma. So, think of B in UVB as standing for burning and bad for your DNA. Finally, we have UVA. These rays have the longest wavelength of the three. Because they are longer, they are less intense than UVB, but they make up about 95% of the UV radiation that gets through our atmosphere. And here's the sneaky part: because they have a longer wavelength, they penetrate deeper into your skin, right down into the second layer, the dermis. This is where your collagen and elastin live, the proteins that keep your skin firm and youthful. UVA rays are the main culprits behind photoaging. They are the A for aging rays, causing wrinkles, fine lines, and age spots. And while UVB is the main cause of sunburn, UVA also plays a significant role in the development of skin cancers. A lot of people see a suntan as a sign of health and vitality. But scientifically speaking, a tan is anything but. It's a distress signal. It's your skin's panicked defense mechanism. When UV rays hit your skin cells, they trigger the production of melanin, the pigment that gives your skin its color. This melanin tries to form a protective cap around the nucleus of your skin cells to shield your DNA from further damage. A tan is literally a visible scar of DNA damage. It's a sign that your skin is under attack and is trying desperately to protect itself. But this natural defense is far from perfect and can be easily overwhelmed, leading to the cumulative damage we've been talking about. So how do we help our skin in this constant battle? We use sunscreen. And this is where things get really interesting, because sunscreens fight this battle on two very different fronts. We can broadly categorize them into mineral sunscreens and chemical sunscreens. You might also hear them called physical and organic sunscreens, respectively. Many modern sunscreens actually use a blend of both, but let's break down how each type works on its own. First, let's talk about mineral sunscreens. For a long time, these were called sunblocks, and the name gives you a clue as to how people thought they worked. The idea was that they formed a physical barrier on top of the skin that literally blocked or reflected UV rays away, like millions of tiny mirrors. The active ingredients here are two naturally occurring minerals, zinc oxide and titanium dioxide. These are ground into superfine particles and added to a lotion. Now, that mirror analogy is easy to understand, but it turns out the science is a bit more complex. Recent studies have shown that while these mineral particles do reflect and scatter a small amount of UV radiation, maybe 5 to 10%, their primary method of protection is actually absorption. Just like their chemical cousins, they absorb UV radiation and convert it into a tiny amount of heat. The key difference is where this happens. Mineral sunscreens sit on the surface of your skin, absorbing the UV rays before they can even get in. So a better analogy might be a shield or a suit of armor that takes the hit on the surface. What are the pros of mineral sunscreens? They are generally very well tolerated, making them a great choice for people with sensitive skin, rosacea, or for children. Because they sit on the surface, they start working the moment you apply them. The major historical downside was the cosmetic feel. Early mineral sunscreens were thick, pasty, and notorious for leaving a chalky white cast on the skin. Think of the classic image of a lifeguard with a white nose. But technology has come a long way. Manufacturers now use micronized or nanoparticle versions of zinc oxide and titanium dioxide, which are much smaller particles. This has dramatically reduced the white residue, making them far more cosmetically elegant and easier to wear every day. Now let's switch gears to the other team, chemical sunscreens. These are also known as organic sunscreens because their active ingredients are carbon-based compounds. You'll see names like oxybenzone, avobenzone, octinoxate, and octocrylene on the ingredient list. Unlike mineral sunscreens that sit on top of the skin, chemical sunscreens work by being absorbed into the top layers of the skin. They form a thin, protective film that acts like a sponge. When a UV ray hits a molecule of a chemical sunscreen agent, the molecule absorbs that ray's energy. This absorption excites the electrons within the chemical bond of the molecule. But this excited state is unstable. The molecule quickly returns to its normal state, and in doing so, it releases the absorbed energy. But here's the clever part. It releases it as a tiny, completely harmless amount of heat. It's a brilliant chemical reaction that essentially neutralizes the UV ray, stopping it dead in its tracks before it can get to your precious skin cells and DNA below. The pros of chemical sunscreens are obvious to anyone who has used them. They are typically lightweight, clear, and spread easily over the skin without leaving any white cast. This makes them very popular, especially for daily use under makeup. The potential downsides? Some people can have allergic reactions or skin irritation from certain chemical filters. There have also been some concerns raised about a small amount of these chemicals being absorbed into the bloodstream. While regulatory bodies like the FDA in the United States have deemed them safe for use, they are calling for more research. Another thing to remember is that you need to apply chemical sunscreens about 15 to 30 minutes before you go into the sun. This gives them time to be absorbed by the skin and to form that protective chemical shield. So we have the minerals, our surface level shields, and the chemicals, our absorbent sponges. Both are effective, and the best sunscreen for you often comes down to your skin type and personal preference. Now, you've picked your sunscreen type, but you're faced with a bottle covered in numbers and jargon. Let's decode the two most important things on that label, SPF and the term broad spectrum. Let's start with SPF, which stands for Sun Protection Factor. This is probably the most famous and most misunderstood term in sun care. SPF is a measure of how well a sunscreen protects you from UVB rays. Remember, those are the burning rays. So how is that number calculated? It's done in a controlled lab setting. Scientists recruit human volunteers. They mark off small squares on the volunteers' backs. One square is left unprotected. The other squares are covered with a precise amount of the sunscreen being tested. Then, they expose the skin to a controlled dose of UV light from a lamp that simulates the midday sun. They measure how long it takes for the unprotected skin to show minimal reddening, which is the start of a sunburn. Then they measure how long it takes for the protected skin to show the same amount of reddening. The SPF number is the ratio of those two values. For example, if your unprotected skin starts to burn after 10 minutes of exposure under the lab lamp, a properly applied SPF 30 sunscreen should, in theory, protect you for 30 times that long, or 300 minutes, under the exact same conditions. But here is the critical misconception. SPF does not relate to the time of day or the number of hours you can spend in the sun. It's a measure of the amount of solar energy. The intensity of UV radiation changes dramatically throughout the day. It's much stronger at noon than at 8 a.m. It's stronger at high altitudes or on a tropical beach than it is in a northern city. So that 300 minutes in the lab doesn't translate to 5 hours of real-world protection. A better way to think about SPF is in terms of percentages of UVB rays blocked. An SPF 15 blocks about 93% of UVB rays. An SPF 30 blocks about 97%. An SPF 50 blocks about 98%. And an SPF 100 blocks about 99%. As you can see, the jump from SPF 30 to SPF 50 is only a 1% increase in protection. No sunscreen can block 100% of UV rays. That's why high SPF numbers can sometimes give a false sense of security. An SPF 30 is generally considered a great benchmark for most people for everyday use. But wait, we've only talked about UVB. What about the deep penetrating, aging UVA rays? This is where our second key term comes in, broad spectrum. For many years, sunscreens were only rated on their SPF, meaning they only guaranteed protection from UVB. You could be using an SPF 50 sunscreen and think you are totally protected while still getting a full dose of skin-aging UVA radiation. The term broad spectrum means the sunscreen has been tested and proven to provide significant protection against both UVA and UVB rays. In many countries, for a product to be labeled broad spectrum, its UVA protection must be proportional to its UVB protection. This is absolutely critical. For comprehensive protection against sunburn, premature aging, and skin cancer, you must choose a sunscreen that says broad spectrum on the label. So, you've chosen a broad spectrum sunscreen with an SPF of at least 30. You've done your research. But even the best sunscreen in the world is useless if you don't apply it correctly. The science of application is just as important as the science in the bottle. And the single biggest mistake people make is not using enough. The SPF value on the bottle is determined in labs using a thick layer of sunscreen, 2 milligrams per square centimeter of skin, to be precise. In the real world, most people apply only a quarter to a half of that amount. When you do that, you're not getting the protection you paid for. An SPF 30, applied too thinly, might only give you the protection of an SPF 10. So how much is enough? The general rule of thumb for an average adult is to use about 1 ounce of sunscreen to cover your entire body. That's roughly the amount that would fill a standard shot glass. For your face alone, you should be using about a nickel-sized dollop, or the length of 2 of your fingers. It might feel like a lot, but that's what's required for the advertised protection. The second rule of application is that sunscreen is not a one-and-done deal. It wears off. Its effectiveness degrades over time from sun exposure itself, and it gets removed by sweat, water, and even just rubbing against your clothes or a towel. That's why reapplication is key. You should reapply sunscreen at least every 2 hours. And you need to reapply more frequently, say every 40 to 80 minutes, if you've been swimming or sweating heavily. This is what the water-resistant label means. It tells you how long the sunscreen maintains its SPF level while in the water, after which you must reapply. Finally, let's remember that sunscreen, as amazing as it is just one tool in our sun safety toolkit. A truly comprehensive approach to sun protection goes beyond the bottle. First, seek shade. This is especially important during the peak sun hours, typically between 10 a.m. and 4 p.m., when the sun's UV rays are at their most intense. Second, use protective clothing. A long-sleeved shirt, pants, and a wide-brimmed hat can provide an excellent physical barrier against UV rays. Look for clothing with a UPF rating or ultraviolet protection factor for even more effective coverage. Third, protect your eyes. UV damage can lead to cataracts and other eye problems. Always wear sunglasses that are labeled to block 99% or 100% of both UVA and UVB rays. So there you have it, the unseen shield, decoded. From the invisible dance of UVA and UVB rays to the chemical gymnastics of mineral and organic filters that absorb and deflect them. We've learned that a tan is a cry for help, not a sign of health. We've cracked the code of SPF and learned the vital importance of choosing a broad-spectrum product. And we've seen that how you apply your sunscreen is just as crucial as which one you choose. The science of sun protection is a testament to human ingenuity, allowing us to safely enjoy the energy and warmth of our incredible star. By understanding this science, you can make smarter choices, protect your skin, and ensure it stays healthy for all the sunny days ahead. Thanks for tuning in to Fun Facts Online. Stay curious and stay sun safe.